Let me thank Dr. Shamara and Dr. Ramesh, both of whom I think are known well, for the excellent presentations they made about the polymer composites and the metal matrix composites. I had expected Dr. Prahlad to talk for a much longer period about his experiences with the composite usage in the aircraft made by NAL, the Hansan, the Cirrus. I will only make a few comments regarding composites, and then I'll invite Mr. Rangareddy to give his comments. I have had association with composites for a fairly long time. In fact, the metal matrix composites group at the Institute of Science was the initiation of MMC work in India when Dr. Rohit came, and I was associated with that. The first thing that we tried at that time was to find out how can you introduce these particles into the metal where there's a question of wetting. The two did not like each other, they always separated, they divorced. How are we going to put it in? So we tried a variety of possibilities and finally found out a very simple method of getting the two temperatures similar of the particles and of the metal would work. It would work wonders. The other thing was, because of the difference in density, the particles always separated out, and they found out that if you just stir the melt in a particular way, the suspension will hold, and we allow the solidification to take place, we got the composite. I think after that, a lot of schools have done this work, and it has gone to many places, and there has been a lot of success. Still, composites are very alien to us. Still, if you look at monolithic materials, all the materials that we know, including all kinds of metals, alloys, and so on, we have known them for thousands of years. People have looked at it in a variety of ways, and they exactly know how they behave under certain conditions, environmental conditions. For the composites, we still don't know. It's not monolithic, it's heterogeneous, and what kind of failures that occur under environmental conditions, we still do not know. I had a project where we looked at all kinds of failures in aeronautical grade composite materials, and we found that the same kind of stressing produced different types of fractures at different times. So we were not able to understand it. Today, I think composites have come of time. We can say we know them fairly well now, and therefore there is enough confidence for people like Boeing and Airbus to use it on the aircraft, civilian aircraft, and give it out in the commercial field. You know that the liabilities are very heavy if there is something wrong, so they have taken this chance to put the composites into the commercial field. That shows that there is a certain amount of confidence that has been built on. When we mention composites, everybody thinks of the high field aeronautics or nuclear and space and so on, but that's not so. I think composites have come into a variety of other fields. One of my friends, Professor Srinivas Iyer, who is now settled in the US, has always been telling me, no, we should go and take the composites to build bridges, to build roads, to build and all that. And he was very disappointed that after forming a FRP Institute of India in Chennai about 10 years ago, his efforts to build a bridge either in Karnataka or somewhere did not fructify. But I'm very happy to say that 2 years ago he came back, and he had his relatives in Jabalpur, who were very big businessmen. They influenced the government and they built a bridge. So there is a first bridge built of all composites in Jabalpur. And I do not know the location, but I know it's in Jabalpur. If somebody has a chance, please go and take a look at it. I understand there's a second order that he has got now to build a similar bridge somewhere in near Bombay. There are tremendous advantages we use composites. I have gone and seen his lab. That's the more important point. In his lab, he was producing columns 50 meter in length. Can you do that in the lab? We said you have a lab 5 crore, you will never be able to do it. So we want to have a lab where you can do real things, then only you will go to the commercial practice. I want to describe to you a small experience that I had with the AR&DB 20 years ago. That was the time when there was the excitement all over the world about adding lithium to aluminum, saying that we'll make aluminum lithium alloys and it's going to replace all kinds of aluminum alloys because the advantage of density and the models that we'll get. So we were also excited and we want to do it. So we got a project from AR&DB and we made beautiful 1 kilogram ingots and made all kinds of theoretical studies and so on. And the R&D committee came and said, present it. So we presented. And I remember it was Dr. Sundaram, who was the chairman of the committee. He looked at the report and he threw it out like this. When I was a young man at that time, I really got very angry. And I said, what is it? What have you done? We have done so much work and you have thrown it out like this. He said, Dr. Dasa, this is not what I'm expecting. I want you to produce material so I can take it to HAL and tell them, use it. I said, all these results will tell you that, take it there. He said, no, if you produce 1 kilogram, 2 kilogram, I am not satisfied. I told him, sir, it's a lab. He said, lab? Yes, you have to do work. Get me that. And that showed me that we must go somewhere there to meet the industry. He also told me, please go and meet somebody in HAL, they will tell you how to do it. And when I went to HAL, I was very happy to say that they collaborated with me and we produced a 70 kilogram ingot. And at the next meeting, I really got accolades from the same committee. And in fact, they gave me one more project. And this is the kind of lab that we want. In composites, it's more important because composites, you have to handle it. You have to get the feel for it. Only then you can say, I know what a composite is. No amount of reading will help. And this is what we have realized. There's one very important aspect of composites, which Shamrao didn't mention. These composites are all made of polymeric materials, fiberglass, reinforced into polymer. I'm one of those who's dealing with e-waste. This polymer composite is going to stay there for years. You're not going to take it out of the environment. So we need to really find out how you can make composites that will not stay permanently. Any kind of metal that you take, you can always remelt, you can do anything, it can go back to the earth and so on, but these composites will not. I'm struggling with some FRP material that I use in my industry. They're all lying there. Every day I go, I just see them, they're just lying there, no change, it's just there. So it's going to be there forever. So we need to tackle this problem, environmental thing with the composites. If we want to do something in composite, we should become more serious. Right now, there is no seriousness in research in composites. I'm sorry to say this. I've been to so many places, I've handled so many things, but I can tell you, we are all playing with it now. If you want to do something, please be more serious. Produce something that can be used by the industry, then only it will prove itself. I'm very happy to note, several of you mentioned, that you have introduced composites courses in your curriculum that will at least bring the students into awareness about composites. But please go further, generate a lab. I'm very happy to see the person from Hyderabad who said they've got all of these facilities. I would like to definitely come and see what it is. I will come sometime. We would like to repeat this, but please note again that if you don't have a contact with the industry, even that lab will be useless. I've been in academics before, I'm now in industry, and I can tell you, only when these two people meet, the result will be meaningful. Otherwise, you will do something, the industry says, I don't want that, they want something else, and you will never meet together. Please bring somebody together and do it. You will have a lot of success in that. In India today, we have a big pool of talent. I must tell you this very good point. I have gone to several countries, and because I was a teacher, I have interacted with a lot of people. I can tell you, our people are very, very intelligent. they are rated very high. But when it comes to practice, they are at the other end. I do not know why. The same people, when they go abroad, they are the people who are creating so many things. On Friday we had another meeting, and there was, I forget his name, Ravi Kumar from NSIC. He was mentioning, he was the director, he said he went somebody with some minister about 15 years ago. On the flight there were 50 Indians who were going to Norway. And he asked him, why such a big group is going to Norway? He said, we have all been commissioned to build some very important thing. They didn't know what it was, but they said, all of us are going to build that materials. And he mentioned that one group of Indians can go and do this very important work. Why can't we do it here? The same group, you're not doing it here. Of course, he didn't go through the reasons for that, but then he mentioned that when they can do it there, we can also do it here. The same thing applies to all situations. Can we do that here? In the field of composites, can we do that here? I remember 12 years ago we inaugurated a composite center at Ambedkar College. I don't know what has happened to that today. I don't even hear about it. There was Mrs. Zaveri who wanted to support this, and she was ready with a lot of money, and he said, can anybody do this? I don't think anybody took that challenge at that time. But I think things have changed. I can tell you there's loads and loads of money in the government, and they're ready to give it to you. If you take a very good project, money is no problem. What is required is this